this video, I'm going to be using my sewing kit to show prokaryotic replication. The two pieces of string make up the two strands of DNA. One is red and one is blue. The spool of thread represents gyrase, which is used to relieve tension in the double helix due to the supercoil formation when trying to separate strands. The thimble represents helicase, which attaches at the replication fork and moves into the fork, breaking hydrogen bonds as it moves along DNA. Here you can see the origin of replication and the replication direction. I have labeled the 5' and 3' ends of both strands. The top strand is the leading strand and the bottom strand is the lagging strand. We can tell the top strand is the leading strand because it goes from 3' to 5', so the new DNA laid down will be going from 5' to 3' direction. The buttons represent single-stranded binding proteins, which coat the single-stranded DNA to protect it, stabilize it, and prevent reattachment. This represents our RNA primase, which lays down RNA primer for DNA polymerase to add to. The RNA primase will lay down multiple primers on the lagging strand. The needle represents DNA polymerase 3. This will recognize the RNA primer and begin to lay down new DNA from the 5' to 3' direction. In the lagging strand, there will be the Okazaki fragments, which form due to the direction of replication. The DNA polymerase 3 can only go in the 5' to 3' direction, so it has to go away from the replication fork in the lagging strand. Now to attach the fragments, we have DNA polymerase 1. This is represented by the eraser. DNA polymerase 1 is special because it has 5' to 3' exonuclease function. So DNA polymerase comes in and will erase the DNA primer as it moves forward and then lay down new DNA behind it. Since DNA polymerase 1 can only lay down new DNA behind it, there will be a nick between the fragments. This is where ligase comes in, represented by the safety pin, and will create a phosphodiester bond between the 3' and 5' ends of the fragments. Now, going back to DNA polymerase 1, if it can no longer perform the 5' to 3' exonuclease function, then the RNA primer cannot be removed. Therefore, the fragments cannot be attached together.